React Performance Debugging. Using React DevTools. In this presentation, you'll learn how to identify performance bottlenecks and improve your React application's efficiency using React DevTools. Find performance bottlenecks. Improve app efficiency. Installing React DevTools. First, open your browser's extension store. Second, search for React Developer Tools. Third, install the extension. Finally, restart your browser to enable the DevTools. React DevTools is available for Chrome and Firefox. Accessing React DevTools. Once installed, you can access React DevTools in a couple of ways. First, use the keyboard shortcut, F12 or Ctrl+Shift+I. Second, right-click on a React component and select Inspect Element, then navigate to the DevTools. After installing, two new tabs, Components and Profiler, will become available in your browser's developer tools. Profiler tab overview. The Performance Profiler measures component render performance and identifies bottlenecks in your React application. Click the Record button to start profiling your application. Track component render durations. Identify slow components. Use interactive performance charts. Recording performance sessions. To record a performance session, follow these steps. First, click the Record button in the Profiler tab. Second, interact with your application as a user would. Third, perform the operations that you suspect are slow. Finally, stop the recording to analyze the performance data. The example code shows a slow component with a heavy calculation inside. Analyzing performance data. After recording a session, you can analyze the performance data. Look at the render duration, component count, number of re-renders, and memory usage. Look for red bars, which indicate components taking more than 16 milliseconds to render. Check for unnecessary component updates. The render duration is 12.4 milliseconds. The component count is 8. The number of re-renders is 5. The memory usage is 2.1 megabytes. Common performance issues. Common performance issues in React applications include unnecessary re-renders, heavy computations, and large bundle sizes. The example code shows a parent component that causes unnecessary re-renders in its child component. The child component updates when the data prop changes, even if the data is the same. Optimization strategies. You can improve React performance using React.memo to prevent unnecessary re-renders, useMemo to memoize expensive calculations, useCallback to stabilize function references, and code splitting to load components only when needed. Here's an optimized solution using React.memo and useMemo. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.